Materials supplied by Microsoft Corporation may be used for internal review, analysis, or research only. Any editing, reproduction, publication, rebroadcasting, public showing, internet, or public display is forbidden and may violate copyright law.
Today what I'm going to show you is a new system we're calling LightSpace. And what we're doing is using some of the new depth sensing cameras technologies to extend the sensing so that it encompasses the entire room. And so what that allows us to do in LightSpace is all of the usual kinds of surface interactions on tabletops, but then we can also fill in the void between, the space between these various surfaces so that we can connect surfaces, so we can move objects from one surface to another just by tracking the person and understanding the 3D shape of the person and where each surface is placed in the environment. Now, one of the things that we're using is this setup, this configuration here of projectors and multiple depth cameras. And together, these are calibrated to a unified 3D model. And we do all our reasoning and calculations out of this 3D model. Allows us to perform various kinds of reasoning to move objects from one place to the other, for example.
So what we have down here is a regular tabletop. Now there's no instrumentation in the tabletop. It's a standard issue Microsoft table. Really, but what we can do is we can project the appearance of the interactive tabletop, and we can track what the user is doing on the table from above, from the depth sensing cameras above. So here are all the kind of typical surface-like interactions that one could assume to get in an interactive surface. But the interesting thing right now is that, for example, these are our research videos. If we want to actually take this research video and show it here on the wall, we can literally just connect through our body. We can touch an object on the table and touch the wall, and now we have a video playing from our last TechFest demo. I'll just pause this for a second. So in addition to all the kind of surface level interactions, we can pick up an actual object and move it to our hand. What you're seeing here is a different representation of that same object. It's a little ball in my hand, and we can move it to another hand like this. We can even hand it over to Andy, and he can play with it some more.
I'll hand it back to you.
Sure. Or we can also take it directly over there to the screen, and now this video that we picked up from the table and played around with in space is now playing on the screen. We played around with a couple other concepts in this space. One is that we can have locations in space actually have special meanings. So for example, if you look down here on the floor, you see a flashing menu sign. And really what this signals to us is that in the column of space right above this space on the floor, there are options for you to select. So if I move my hand here through the column of space, we actually get to see different options of selection. And to select it, we just have to wait a little bit in here. And now we selected to change all our videos and photos from our research videos into our personal baby photos from Andy and me. And in addition, last thing that we can select here in the menu is to highlight every person in the space. So right now you're seeing me highlighted as blue. So the system tracks me in the space and I'm highlighted as blue. If some other person comes in, like Andy in here, he's going to be green. So this brings some interesting opportunities for us to track people and infer the interactions between two people. So if we shake hands, we're going to change colors. We just merged, and we have a different, the system detected that there was an interaction between us.
So this highlighting example is just one thing that we can do with the 3D data that we get back from the depth sensing cameras. In the future, we'd like to think more about different kinds of things that we can do between surfaces. And in particular, we're talking about what we're calling deviceless augmented reality. Most people have seen augmented reality concepts where maybe we're using head-mounted displays or see-through goggles, other kinds of devices that you have to wear, and that can be kind of clumsy. With LightSpace, we can project the graphics directly onto body parts or your environment, for example. So maybe you're late for a meeting, and the way that you figure out where you have to be is you pull out your hand and it shows you where to go, and then maybe even in front of you on the floor you see some kind of arrow that shows you exactly where to go. So this is an example of some of the things that we'd like to look at in the future. So I'd like to take you through some of the processing that we're doing in LightSpace. So this window shows a lot of the representations we're using. So for example, up here at the top we have the three camera views. This is their actual data coming off the depth sensing cameras in the raw. And what we do is we combine these views into a single 3D model of the space. And we can do that because we have the cameras and the projectors calibrated to this 3D model. And so you'll notice that as Benko moves around in the scene, this is 3D models updated appropriately from these inputs. Now another thing that we're doing is illustrated over here. We can take various projections of this data for various purposes. So for example, we have this simulated surface representation here, the table with the pictures on it. Now as Benko starts manipulating these photos, we see this particular projection now shows the kinds of things that we usually get with surface, these various contacts as they're made. And so that's just a quick example of some of the things that we can do with our 3D model.